All right. Good morning, good afternoon, good evening, good people. Not sure when you're gonna watch this, so hopefully this little intro can kind of help and bring you some information that is necessary for you to move on to the next grade, the next content, the next subject, right? And so as we're talking about this information that we're gonna have on the screen, I just want you to understand this is just a brief intro. I'm not getting into too much detail. If you would like to ask me questions while still in class or throughout the summer, we can do that. But this is just a brief intro, right? So now for Unit 1, the whole focus, the whole goal is on the quadratic and radical functions. And so within this unit, the most important piece is creating and interpreting quadratic functions, right? Yes, you will need to create and solve quadratic equations with real and complex roots. You will need to be able to create and solve systems of linear and quadratic equations. But the basis of this is being able to create and interpret quadratic functions. All right, this unit 2, is about polynomial radical functions. You will get some information through Mathia to help you understand what a polynomial function is. But a polynomial function is just one where the equation is y is equal to ax squared plus bx plus c. And so that's your standard form of an equation for Algebra 2. And this is the backbone, this is the basis. The most important piece here that you understand is creating, graphing, and interpreting polynomial functions, right? When you have um, just y equals x, what does x look like, right? Y equals x squared, what does x squared look like? Y equals x cubed, what does x cubed look like? So how does it change? How does a graph go from one polynomial to another? And what are the changes to that graph in that line? Or, you know, does it turn into a parabola? Is it just a line? You know what I mean? What do those look like? And identifying the effects of transforming polynomial functions. Unit 3, you will start to get into more, a little bit deeper of um, complex polynomials, and you're moving to exponential and log functions, right? So logarithmic functions and exponential functions are very difficult. This is another reason why I gave you some coursework in Mathia so that you can get a backbone, a basis, and understanding of what they are and what they look like. But here, everything is important here, but you want to be able to create, graph, and interpret exponential functions, right? That's one piece. You want to be able to create, graph, and interpret log functions, right? And so those are the backbones, those are the understandings that you build everything else off on this. You have to be able to recognize what an exponential function is, what a logarithmic function is, how to create it, and how to graph it. So you do have properties within this unit that helps you understand um, what exponential function equals a logarithmic function and how to use those identities in order to solve equations, right? And so again, that's what that will be for that unit. All right, unit 4 now, we're kind of getting you prepared for pre-cal, right? So you're getting heavy into trig functions. No different than what we did in class. You're just taking a deeper level, deeper numbers understanding of it, right? And so here, you want to be able to create, graph, and interpret trig functions, right? You also want to be able to identify the effects of transforming trig functions. You all always want to be able to prove and apply trig identities, right? So the trig functions, sine, cosine, tangent, and the inverse functions have properties, so they equal something. And so once you get into this section, it's going to help you get a little bit deeper understanding of how to apply those identities to problems so that you can answer questions and solve problems. All right. So now these are the three forms of a quadratic function. You have the vertex form, which you'll mostly deal with, the factor form, and then you have a standard form. Standard form is what you're used to seeing. Factored form, a little bit like you know how to factor at this point. You know how to do the full method. You know how to do these things, but you might not spend extensive time with it. In the vertex form is when you have a graph and you want to be able to find out, hey, what's the equation of this graph? Uh, if you're given a vertex form, show me the graph of this equation.